Hi all of you. So in this lecture we are going to prove Snell's law by wave optics. So let's say this is an interface which is separating two mediums. This is medium 1 and this is medium 2. Medium 1 has refractive index mu1 and medium 2 has refractive index mu2. And a parallel beam of light is striking the medium 1 interface. So a parallel beam of light strike कर रही है इसमें. And this will be the incident wavefront that will be perpendicular to incident rays. So these are the parallel lines. And this is the incident wavefront that is always perpendicular to the rays. So incident wavefront, incident wavefront. Now, as this light ray will strike, so we draw the normal, and this angle is said to be angle of incidence. So this ray will bend in medium 2. Let's say bend because let's say ki mu2 is greater than mu1. You can await also, and this angle will be the angle of refraction. So let's say this time is when the rays strike the medium, this time is t equal to 0. And after time t, this ray has traveled from this point A to B. And during this course, this ray, the extreme ray, has traveled through this point to this point. So B to something, yeah, C to something D. So when the light ray A has traveled to B, the light ray C has traveled to D in the same time. Okay. So if we write the distance AB, we can write speed into time. And we know the speed in the medium is c by mu2 into time. Similarly, we can write distance CD. This is speed here is c by mu1 into time. So we have written these two distances. Now, at time t, this ray reaches here and this ray reaches here. So if we join these all rays, we will get a refracted wavefront. Refracted wavefront. And we have drawn it for two extreme rays. If you draw for this ray also, then this ray will reach here. If you draw for this ray, then this ray will reach here. So you can draw for any ray, you will get this refracted ray wavefront. This one. Now let's start the proof. कि कैसे इसको prove करें. So this angle is I, and this will be 90 minus I, so this will be I. Similarly, this is R, so this is 90 minus R, and this is perpendicular, this is also R. So I can write sine I upon sine R from these two triangles. Sine I will be equal to perpendicular, that is CD, upon hypotenuse, that is AD. Similarly, sine R, we can write perpendicular AB upon hypotenuse AD in this triangle. So this we have written from triangle ABD, and this we have written from triangle ACD. Now AD will cancel out. This will give you AB upon CD. Now we have calculated already AB. AB is C by mu2 into T upon C by mu1 into sorry, this will be CD by AB. So this is by mu1 and this is mu2. So this is equal to sine I by sine R. So sine I upon sine R is equal to mu2 by. And this is the Snell's law, which we were trying to prove. तो इस तरह से इसको prove किया था. I believe कि आपको clear होगा ये. So please comment on the video and share my channel. And for more such videos, just follow me. Thanks for watching.